Hey everybody, me Keith, Elder Rock, back here on the bench. Sorry it's been so long, my day job is like really taking a lot of my time. So we're back on the power supply, the Williams power supply saga. So I had my power supply, which we actually went through and rebuilt, which I think is good. So when I picked up this hoard of stuff, I think the transformer was bad, or I might have let the smoke out of this one. But here in Thailand, we can have these rebuilt. So I took it out to the market. I had the original Williams power transformer rebuilt, and I had 2 extra ones made. I wanted to see if they actually have good quality stuff. I think they are. So today's video, we're going to go over the Williams transformers. Transformers can be a pretty big topic. We get all science and math and stuff like that on it, but this is Arcade Laboratories. So this video is to help you test your transformer, your Williams transformer, but probably some application into other manufacturers, Nintendo's, Bally, Midway. There's kind of some application there together. But we're going to go through some Williams schematics together to show you some differences in the transformers and the taps. We're just going to keep it very basic testing to we're going to check for our voltages, make sure, if you take the time and rebuild a power supply, that your AC current is actually proper. You don't want to damage or you hurt yourself. You don't want to damage your power supply or your board or your monitor. So we're going to go through some basic transformer tests. At least in all my equipment, I like to run all original stuff. Low noise. When these things were manufactured and engineered, they were based on a certain noise level in your boards. And I know switcher supplies are fine. I use them, but I think there's a demand for all original stuff, and that's kind of what we want to do here in this case. We'll do some switcher supply stuff later, but okay, so let's go ahead, move the camera into the play field and get started with this. Okay, we're back on the bench. So I got a lot to go over, so let's just get started. So I got the test bench set up to test these transformers. So I have a 220 to 110 step down transformer. So this is going to provide 110 volts AC. Now also behind here, because I live in Thailand, so we have 220. So we have 220 volts AC here at 50 hertz is our frequency here. So part of the, kind of being safe. So either way, so I have a double fuse block, one for my hot, one for my neutral, and a multimeter. If you notice, I have a new multimeter I got at the market. So it's definitely, in that one video, we fixed this guy. He's good to go. But this guy has a lot of new features for me. I have amperage, I have frequency, have duty cycle, has a hold feature, and what I was really after is just a meter with a range, a manual range. That other one, he's only auto range, but sometimes I like to look at things in different scales. Anyway, so this is the test bench. If you set up, always have a fuse. Do not directly connect your power to your primary side of the transformer. So just kind of be safe. Like I got this guy screwed. He's screwed right down to the table because I don't want him to move around or anything. And I had a nice harness all built for this guy, but he won't work on those guys. So for today's video, we're just going to use alligator clips. I'm not real happy like demonstrating it with kind of a smaller gauge wire, but just with no load. Just taking measurements, I think we're okay. Not proud of that, but we're going to roll with it. Okay, so that's our test setup. So now the science stuff. We still need to talk about the science stuff. So in today's video, we are going to do both 110 and 220 testing with these transformers, because I hope I have an international viewer. There are a lot of people in Australia, Asia, and UK that all have 220, 50 hertz frequency versus US that we have 110, 60 hertz frequency. So the thing to remember about these transformers, any transformer will change your current, but it will never change your frequency. So even in my 110 converter here, we're still gonna get 50 hertz out of it. So even though it's a 110 transformer, we're still only going to get 50 hertz. Most of the world uses 50 hertz. America uses 60, but you know what? There are arcade games everywhere. So, okay, so let's go back to the schematics. This is a Williams video. So, let's just continue for today. So we're going to do both 220 and 110. So basically the really sciencey kind of stuff that we're going to talk about, not sciencey, but is properly setting up your transformer in series or parallel. So basically, depending where you live is how you're going to have your transformer set. And we're going to talk about the Williams schematic, about how to kind of read it and understand what's going on. So basically I already made a note. 110 volt AC, your transformer is going to be set up in parallel. So basically, like, we have multiple windings on our primary side. So the green in my little drawing here is each winding in parallel. So basically, you're supplying 110 volts to each primary winding. So, and then versus 220, we're gonna supply 220 across all of the windings using a jumper. So that basically will still apply 110 volts per winding, but in series. So, okay, so with that, let's just keep talking about that. If you're looking at the schematic, and thank you, Sean and Steven, actually, for helping me kind of with this. So on your diagram, on your Williams drawings, it's going to show two different configurations. And see, it says Note 3. There's only one print I found on all the Williams boards that have the Note 3. Like, the Note 3 is actually chopped off in most of the manual downloads. Note 3 will be lost. But basically, Note 3 is saying that these outer jumpers, white-red jumpers, are for 110 to run your games in parallel. And the jumper for this dotted jumper is going to be your series, running your transformer in series. So being able to understand that, kind of what parallel and series is, will help you wire up your transformer correctly. So kind of looking at the drawing, if you kind of break it down a little bit, you can see that they have one winding here, and kind of the color helps, kind of break down each winding. And then my yellow here just kind of shows the jumper. So let's come in from the beginning, and the orange is your AC in, no matter what voltage you have. So coming in series or parallel, the power still lands at the same place. Now I should probably switch to my other drawing, because this is a joust drawing and they're different. So let's just kind of go over the prints, and then we'll get back into the series parallel wiring when we're actually doing the testing. So this is just some preliminary testing I was doing last night. I was kind of playing around with. There's our worksheet we're going to work off today. Okay, so this is the actual Defender tab. This is the actual Defender drawing. And you can see versus the other one, the joust is going to have 2 extra taps on the secondary side. This transformer does not have that. So kind of matching up, and be careful when you're wiring things up. You have numbered taps on the transformer, and you have numbered pins in your pin, like pin locations, tap locations. So don't don't get those confused. So on your transformer, they're all going to be labeled taps 1 through 4. This is the primary side. And then on your secondary side, you also have labels. This guy's going to go from 9 to 17. And then your, I think there's 2 of them. There's Joust and another one. It's going to have 20 taps. It's going to have an additional tap, 2 taps for, I think, a 6.5 AC output. So, just get familiar with your drawing, or if you're just like super experienced and you don't need the drawing, that's cool. But I always kind of like to double check with the drawing. So yeah, 6.3 volts extra for Joust and I think Robotron. Okay, so kind of going through the drawings again. They're very similar, so be careful. This is what we have. We have a Defender, and you can see we have 4 taps on the primary side for 1 winding, 4 taps on the primary side for a winding, and there is no additional winding. So that corresponds more with the tap situation on our transformer. Going further. Okay, here's the Joust. It's kind of like the one I'm working off of, but not marked up. There's an additional winding on the secondary side for 6.3 volts. But see the difference? See the difference there? Where your power is landing on tap 8 right from your AC coming in versus tap 7 on the Joust. So that's going to energize this winding kind of in a different place, but I think that's what breaks down for that 6.3. It's kind of like where you're tapping your power. Okay, the Joust, same thing. Same thing with the Joust. Have an extra winding on the primary, different tap location on the secondary, different tap location on the primary. And I printed out this super tiny Robotron because if you actually want to see the notes about note number 3 about the 110 220 C note 3, Robotron actually has note 3, and it basically just talks about the jumper wire difference between 110 and 220, 230 in here, but whatever. And then what is this guy? I think he's just an extra. I think he's from the Joust, and see the notes. The notes just get cut off on in the download when people upload them or download them and scan them in. But hey, I'm grateful they're there. That's why you kind of got to be a good tech and really understand your schematic and drawing. You're going to damage your own work or hurt yourself, and that's not cool. Okay, so what's next? So let's go back to my drawing I had marked up with the colors. All right, so we're going to go ahead and fill out the sheet together. So how do you test your transformer? Okay, so the manufacturer does give a percentage limit. It says that your required voltage should be plus minus 3% of your required voltage. So I just went ahead and did the math and created a lower limit and upper limit for each voltage that we're looking for. So when we test our voltage, we're hoping that we're somewhere in this range. And I guess if you're way off in left or right field, you're just going to have to make a good decision. And another huge thing to keep in mind, we are testing these transformers with no load. So our voltage, our actual tested voltage is not going to be exactly where it's engineered to be without a load. I don't really have a load. I'm just going to go ahead and kind of see where they land, and just let my power supply be the load when we get close. I'm just going to make sure that we are somewhat in here. Hopefully we're in here. I know I already tested them, so we are pretty in here. I have some that are kind of off in right field, just a couple volts, but I think we're just going to roll with it. I need to get a, tell my friend Steven I need to get a proper like decade box or some sort of load for testing. All right, so this is our worksheet we're going to fill out together. We're going to go through each transformer, tap, and we're going to set it up in input voltage for 110 and 220 for transformer 1, transformer 2, and transformer 3. So we're just going to go through and take all the data, and this will kind of verify whether the quality of these guys are good. I already know right now, like the wires that they use 18 gauge wire versus like a 20 or 22. I'm not like super happy. If I would have told them to use thicker wire, they would have. But if I ever use these, I'll probably unsolder all of these wires and use a heavier gauge wire. But that's just me. So we're going to go through some preliminary testing here. Okay, so without getting all super sciencey and nerdy, we're going to do some resistance checks first. We're going to take our meter to we're in auto range, so we're just going to do some resistance readings first. I'm just going to like basically cover some stuff here with you, so you can test whether the windings are like opened or shorted. So really, between a winding, you're looking for like very low resistance. The lower the better. So the low resistance is going to indicate no short, and it's going to indicate, if you kind of do the math deeper, it's going to indicate the size of your conductor, the size of the windings inside. So kind of looking at, let's just kind of look. So basically we know we're not shorted. That's good. That's okay. That's pretty low. 2.9 ohms. I'll take that. Now, another thing to note, these jumpers have to be here, and let's take some more measurements, and I'll just keep talking about that. And so this should be just a little bit, should be pretty much in line with this guy. We're just going down the winding. 2.9. And this is a good thing to do. Like, you want to do this before you apply any power. 2.5, it's a little lower as we're getting near our points. 2.5. Okay, no open. So these terminals actually have a really thick coating of glue. I know I could use the wires, but I want to measure right on the taps. 3.1 ohms. That's good. 2.6. These are jumped together, so it's probably going to be the same. And it's the same. Now let's measure between the windings. Open. Now this is important to measure between your windings. If you have multiple windings on each side, you want to measure between them to make sure there's no short between your windings on the same side. Okay, I know, yeah, I'm kind of probably could get more in depth, but I know a lot of arcade guys, people, not everybody is electricians or whatever. Check out the secondary side. So this is the problem. When you go online and look at videos, they're going to show you how to test transformers with, just maybe one output on the secondary side, sometimes two. Like sometimes you have a center tap and a couple voltages, but these are a little bit different, and they're not too hard to understand. Okay, so let me just pull up the print, and I'm going to show you the secondary side. And this goes for all your transformers, like no matter what games that you're working on. Yeah, we're just going to use my Grizzly. We're just going to use my Grizzly colored up one here. Okay, so basically, you've already broke down your voltage. The transformer has stepped it down into the voltages. Yeah, I won't even talk about that. How many windings in the core and all of that, whatever. Okay, so basically here, it's just going to show you. Now, this is your primary side, your voltage coming in. This is your secondary side. This is the side that we're looking at right here. And you can see that each tap is called out, 9 through 17. So I'm just starting up here at the top. So it's calling for 117 volts between tap 1 and 2. You kind of come down on this side. 11.3. This is the one, I dial into because this is going to run your 5 volts regulated. Yeah, so, and it's good, like, follow it through, kind of get a good idea of what it's actually running, so if you have problems on your board, you don't have your, 12 volt regulated, or your positive 5 regulated, or your negative 5 regulated, it kind of gives you an idea like where all that stuff generates. Okay, so this one, we have a center tap. We have 11.3, the center tap, 11.3 on 15, 16, 17. Come down on the secondary side, we have a 20 volt AC tap, 11.5. Yeah, I know I'm not working off the right print. I probably should for my video, but we don't have this. These taps do not exist on this transformer. Okay, so I wonder if I can kind of get both in here. So you guys are just going to have to listen to me talk boringly. Oh, maybe we can go like this a little bit. Something like that, maybe. Okay, so what I do, I'm just going to start at the top. On the secondary side, 9 and 10. Wait, all right. 9 and 10, so this is 117 volts for your monitor. So between these windings, between these taps, you're looking for a low resistance. You don't want it to be shorted or insanely high. It could mean corrosion. It's almost an open. But if it's really small as well, if it goes down like 1 or 2 ohms, that's okay. Just can signify the size of your windings and stuff like that. So don't be scared if it's too low. Okay, so that's, maybe I can get it in here like that. Okay, so that's the 117 volt line. Now let's go to our center tap next. So our center tap to one of the taps should be low. It's very low. That's not 0.2. That's okay. .3. That's okay. And I'm using like super sharp poker probes. If you use your regular probe, you probably will not get through the conformal coating and glue on this stuff. So that's why I'm able to get away with probing these. Okay, tap to tap on the 11.3. So it's going to be like whatever each side is doubled. And I can't go down any lower on my ohms, or I would show you. There's 0.3. So like if you remember, we were probably 0.1, 0.2. It was probably 0.3. Okay, so those guys are good. And then let's do this is another 11.3, 13 and 14. Yep, this is kind of like in our world, like with my students, this is like safe to turn on checks. If you don't know a transformer, take some resistance readings before you power it up. Okay, low resistance reading. I can accept that. And then this guy is, excuse me, this guy is 20 volts. This is your 20 volt AC tap. Okay, so a thing here, same thing like we did on the other side. So from winding to winding, you want to take a resistance. So this is a pair. So you don't want him shorted to any other winding. Just call it a winding for now. See, they're all isolated. Should not have any continuity to any other circuit. Okay, we kind of just did this one, but we'll do it again. Crisscross. Open, 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 open. That's good. I already did the other one, so I won't make you guys sit through this again. Yeah, I already did this last night to the other ones, but I just wanted to show you. Safe to turn on checks. And then kind of ran through all those, so All right, on this tap, we've technically hit them all, but we'll hit them all again. Open, open, open. That's good. Center tap, center tap. Yep. See, basically, you just don't want to turn this thing on and have any of these winding shortages. It'll sizzle and fry and smoke, and there could be multiple degrees of that. You could have a little spark, or you could have a big spark. But you know, we don't want any sparks. So just kind of a nice, safe to turn on check there. Checks low resistance across your windings. Okay, so I think we're ready to power on. So let's go ahead and power on. We'll get our spreadsheet, our worksheet. I'm like back in class with my students, but anybody watching, I hope you like this kind of stuff, and I really do. If you have any comments or feedback, whatever. So I'm just gonna go. Let's start with an unmarked one. We're gonna go to the Fender one that I already kind of have here. And let's see, maybe we can draw on this guy together. Yeah, I know my. Okay, so let's go ahead and wire this thing up. Now, on your cabinet harness, kind of where your jumpers would go. So that is connector, that's P1. So I don't have a cabinet and I don't have the jumper, so that's okay. We're on the test bench. We can do whatever we want. So your other end of the harness would have the jumpers, or you can make jumpers here. But we're just going to go ahead and we're going to go ahead and clip right on. All right, so we're going to do the 120 first. So basically, we're going to go ahead and connect up pins. Okay, so 1 and 5 with either a hot or a neutral, and then 3 and 7. Actually, it's going to be 4. It's going to be 4 and 8 on this. So let's go ahead and get our jumper set up. All right, so I have. Okay, so we're going to go 1. We're going to go 1 and 5. Okay, and then our jumpers, to make it parallel, are going to be there's 1 and 5 and 3, well, and 8 and 7. Okay, so now if we kind of look at what we've done here, I'm going to go back to the colored one. I just think it's easier for learning. So what we've done, if you follow, let's just start with 1. We come in, we land on 1. It goes through the jumper to 110 to 5. Okay, actually, I think I dorked that up. Okay, so yeah, getting this guy wired up. We're going to, for series, I went back to the other drawing, unmolested, plus it's the right one. I don't want to confuse anybody. Okay, so we have one of our hots coming in, tap 1. And then we have another one of our hots going to tap 8. Which we do. Okay, so they're back there. They're already alligator clipped on the fuses. Okay, so for jumpers, let's just kind of look at our jumper. So this is for 110. So let's just start with pin 1, not pin 1, tap 1, and then he's gonna go to 5. So let's get him. Clip him on pin 5. Or tap 5, and then for the other one, for 110, we go from 8 Follow it around to 4, right above it. Now, I don't think we're going to do this, but if you are in a different, if you have different voltages, if you have something not standard, something different, higher, 140, 130, 230, 240, or even higher, 120, 130, you can move these. There's another note in here, and I was playing around with that last night. There's another note in here. You can actually, and I kind of know this from my job, you can move this whole thing in one tap, and it will actually increase your voltage. So anyway, there's a little room for. All right, so we're just gonna, okay, so we're wired up for 110. I think all the jumpers are in. Let's go ahead and power on. I just get so nervous because, like, at my work, like the equipment is so sensitive. Like, we have to, there's always like a crowd of people when you power anything on where I work. So, kind of bad habits. I know some people just throw it on there and throw the switch, but there is merit in actually checking your work before you turn it on. Okay, I like it. I got two power. Okay, power supplies plugged in. This guy is on. Let's go. Boom. Okay, so we're on. So let's just go. I won't do this every time, but let's check our voltages coming in. Kind of like any kind of check, right? If you're having problems with your arcade, just start at the beginning. Start at the beginning. 111 today. Last night, after using this power supply for a while, it was dropping down to like 106 volts AC. It's up there where it should be now. Okay, so yeah, that's good. Let's check some voltages. Let's just check some voltages here on the primary side. So let's check, I guess, where they come in. Okay, good. So we know we have power on our taps. And now when you start measuring voltages on your other taps, they're going to be a little bit different than your primary voltage. But there's a math thing there, and I'm okay not going into that. Okay, so we have primary power there. All right, let's see if we can spin this thing around without shocking ourselves. All right, spreadsheet time. So let's start taking some numbers. All right, I know you guys probably won't do this at home, but I recommend doing this at home. All right, so let's, we already went through the schematic once about what everything is. So let's just go through. So this is for the 117. We got 122.6. Okay, so input voltage, 120, 122.5. Okay, so let's do our 11.3. If I can get on it. 10.3, 10.31. Let's go over to the other one. Should be the same. 10.31. It's going to give us like the double. We're not really worried about that. 10.32. Okay. So 120. Oop, I forgot a, oh crap. I'm gonna have to I forgot the other tap here. 10.32. Okay, let's do our 20 volts AC. So right here we're looking for 20. Yes, 20. So we got 2342. It's a little bit high. And then for the last of this 11.6. And this one was kind of low last night too. Okay. 11.5. 8.68. So I wouldn't get too concerned. 8.68. Nope. 8.68. I wouldn't get too concerned if some of these voltages are low. I think even if they're out of spec 3%, it's because it could be because it's no load. I can't say it's bad even if it's not in spec. All right, so what we got for 117? 117, this one's a bit high. 10 for this one. This one's good. For 20 volts, this one's high. For 11.5, I know that guy's gonna be low. He's low and he's low, but kind of gives you a baseline, kind of gives you a baseline. So really that's the transformer checked. I'd say if you kind of get your percentage, your go no go, take your data and kind of go from there and make a decision. I don't have a load. If I had a load, we would see these numbers change. When we actually hook up the power supply, we'll come back. So okay, so let's hook up for 220. Let's do it on the 220 side. I was kind of curious because I was kind of curious if it would affect. Kind of curious if it would affect the output voltage, and it really does not. But we'll show you. Okay, so same deal. We're gonna just take our jumpers off. We're gonna take the 120 jumpers off for 220. For 220, we still land on the same place, but let's look at the print. Let's look at the print. For 220, this one's not even on here. See, some of these prints let's go to my print. All right. This one, so basically, this line 6 is going to come down to 5. So those two will get removed. It's not a both thing. It's an either or thing. So we want to jump between pin 4 and pin 5. Now if we follow it, pin 5, come back up, yes. Pin 5, or tap 5, follow the 220 line, and we're actually going to 4. So we're going to go 8 to 4. 3 to 5, let's see. 3 to 5, 8 to 4, 3 to 5. Yeah, actually we're going to go 8 to 5. Jumper 3 to 5. Okay, we just took a little break there so I can set up for 220. So basically what I've done, I unplugged from the 110 to 220, and then we made our proper jumpers here. So, I kind of did a lot of talking there right before we cut. But basically, let me get back with the colored picture here. And just really kind of just simply looking at it. Make sure I don't touch anything there. Just real simple. The only thing for 220, since we're going to run it in series for 220, just visually kind of see we have 2 windings, and we're just going to bridge tap 5 to tap 4, and then kind of coming over to the proper print. Kind of makes it a little easier to see. You have two windings. You can see parallel, parallel, but for series, we're just going to connect pin 4, tap 4, and tap 5, which we've done. So let's get the voltmeter back on, and let's start probing around here. Let's check on the one side of the fuse. Wait. AC. All right, 226. So be very careful probing around not to short anything. 226. Okay, let's measure between our windings. So actually now between tap 1 and tap 8, we should have 220. We should have the same. Okay. So we know our winding is energized. So let's look at each winding. Now see there? Now we're measured, we're probed on each winding. We're on pin 1 through 4. So that's one winding. You see it's the same. So it's 112 volts AC. Same as when we have it wired in parallel for 110. So it just has to do with your wiring configuration. Now let's come up top to the other winding, and it should be about the same. Okay, good stuff. So now carefully, let me spin this guy around, not to shock myself or short anything. I'm just an extra cautious dude on the bench. Just kind of creature of habit, creature of my environment. Okay, so let's just run through them again. I won't bore you with everything. Okay, so let's start with our... Oh, we got to record. Let's record our data here. Move these out of the way. Okay, so now we're at... Let me get this up here. Maybe you can actually see me right a little bit. Okay, so now we're actually at 220, 220, 220, 220, 220. All right, let's get on it here. All right. 123.7. So that's almost a whole volt more. That's almost a whole volt more. It dropped down. 122.7. That's spot on, really, the other one. All right, so let's do our 11.3. 10.34. See, it's pretty much the same. 10 point... Oh, let me get back on it. 10.34. Go center tap over to the other one. 10.35. Actually did that one down here. 10.35. All right, let's do our 20 volts. And I like the micro probers because they're pretty well shielded, except for the tip, so you don't, not as easy to short things together when you're probing, and the sharp pokey lets you get a good contact. All right, that one's identical. Wait, 23.24, and then let's do our what is it, 11.5. And that one's still a little bit low, but no load. So I think as far as our tolerances go, our plus minus 3%, it's going to be the same thing. That one's high, or 117's high. The 11.3 is spot on, which is good because that is for our 5 volts, which is pretty important on our board. Our 20 volts is a little bit high. Our 11.5 or low, and our 11.3 or low out of tolerance. So, but again, not you know, it's not under load. So, okay, we're going to do one more transformer. So that was the rebuilt one. I'd say, you know, it all looks pretty good. Let's power down, kill ourselves, and let's get another transformer up here. And we'll disconnect all of our jumpers. Now that rebuilt one is actually one I'm going to use in my power supply. All right, so let's get this guy back up here. 1 through 8. Let's get the primary side up here. We'll wire him in. Okay, so we're gonna power both windings, and we're already on 220, so we're just gonna run there. So that is the beginning of the first winding. That's the end of the second winding, and then where's my other jumper? This is the white one, and this is the end of the first winding. And we're going to take it to the beginning of the second winding. Okay, hopefully no smoke. I do have the wires for both the primary and second side. They're cut with no cap or insulation, but I wound these up and kind of checked them out. But you just want to be careful where your wires are and what they're touching when you power on. I wired these up. I feel pretty safe that they're not. Okay, powered on. Okay, we're going to call this guy T2, like the Terminator T2. Okay, check on the other side of the fuse. Okay, 220. So let's check the winding, both windings end to end, 220. That's good. Let's check each winding individual. Should be, remember, it should be 110-ish. That's good. And 110-ish. That's good. Might actually be better than the rebuilt one. All right, so same deal. We're going to try to spin this around without touching anything. I don't actually like that. Okay, we'll have it here. Yeah, I don't like to be shocked. I don't know about you guys. Okay. Okay, so let's just run down through. We'll do the 117 taps. Call that 121.1. All right, so 121.1. Let's do 11.3 from center tap. .26. That's almost the same as the other one. 10.26. We'll do the other 11.3. Same. 10.26. Let's do our 20 volt AC taps. 23.28. 23.28. And let's do our 11.5. Still low like the other one. So that's 8.63. 8.63. Okay. Let's I'll shut that down. Snag the plug. Plug it into our 110 converter. Plug the converter back in. He shut off, okay. And then let's spin him back around and get him wired up for 110 or parallel. Remember, we're gonna go, yeah, we're gonna get him wired up for 110 parallel, which is, we're gonna go 1 to 5. And 4. No. And 4 to 8. Let me double check that. Let me double check. I'm always double checking and doubting myself. Yeah. Let's see. 1 to 8. Okay. So just to double check our work, you should always double check. I mean, there's confidence that comes after a while, but man, you know, once you spend money on stuff and time, you don't want to be frying it. Okay, so one tap landing on 1, the other on 8 because we are actually on the joust. 1 on 8, and then 1 on 8, and then 5 is going to go to, oh wait, I can't read it on camera. Let's see, 5. Dun, 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 dun. Tap 5. 5 to 1. 5 to 1. Okay. 5 to 1. And it's going to be 4 to 8. And then we're going to go follow that up. Let's see, 4. Wait, I'm losing it on my way up. Yeah, 1 to 5, 8, 8 to 3. Okay. Actually, 8 to 4 because we're on the joust. Okay. Hopefully no smoke. Wait, okay. That part always makes me nervous. Again, because of where I work. Like, man, you short something out where I work is a bad day for a lot of people. Okay, 110. 110. Okay, so let's check across our one winding. 110, that's good. You know what? I didn't go through the short check with you guys on this one, but I already did it last night. So we are good on our short checks. I did that last night. So let's spin him around so we can get the secondary side facing us. Wait. Okay. Did I see that okay? All right, so let's run through and just log the 110 voltages, and then we'll compare a little bit of compare our data, and probably just wrap this video up. 121 on the money. And get these like some chopsticks here. 121. 121. These guys should be the same. Get on there. All right, 10.25. It's kind of the same. A couple millivolts off. 10.24, I'll take it. 10.24, 10.24. All right, let's do our 23.26 volts. Which is only like very, very, very similar to when we had it hooked up in 220. 8.63, that's the same. So 8.63, okay, power down. All right, guys, so that's pretty much it for checking these transformers. I already checked that one last night. It's the same as this guy and same as this guy. So let's kind of go through here. Let's go through and just look for, I like data analysis. So our 117 volts, 110 and 220, transformer 1, transformer 2, they're pretty close, like a volt and a half off. 220, same deal, a little bit more than a volt and a half. These guys, pretty much the same. The 20 volt, it's a little high. That's the only one that's like actually high, out of limits, because these are our thresholds, like our upper and lower limits. But those are loaded. Those are loaded limits. I don't have a load on here. But, you know, this is where I always say it, you know, as technicians, we have to make good decisions about, you know, our next step and what we want to do. When the data's not perfect, when the voltages aren't perfect, what does it mean? You know, is there something that you're missing? You have to kind of look at a lot of things. So 11.5, that guy's low. 11.5, let me look at what he does again. 11.5. So he's running low, and he's the negative 5 volt. He'll run the negative 5 volt DC power supply, a regulator supply. Yeah, maybe under load, you know, since it is getting not regulated, but he's getting broke down into DC there. So maybe that's enough voltage. We'll just have to keep an eye on this. I think I'm good to go with these numbers, trusting it on my new power supply. And then 11.3, yeah, okay. Just some notes I wanted to talk about. Oh, amperage. Before we cut, let's test amperage. I should have done it on the other board. Crap. All right, so right now, how to test amperage. So, how to test amperage, I'm going to show you guys. And that's why I like my new meter. So let's go to the amperage AC setting. So amperage, you need to check in parallel with your supply. So basically what we'll do, we'll pop out one of these fuses. The meter will finish the circuit, complete the circuit, and then give us our amperage reading. Let me see if I make sure I'm off. Okay. Yeah. No, just kidding. Shouldn't do that. Okay. So now if we power on, let's see if I can hold these without any major difficulty. I'm hoping that we'll see how many amps at least the transformer's pulling. We're on 220. I didn't disconnect anything. Okay, let's power on. Wait, nothing happening. AC should be pulling. Oh, no, I'm an idiot. We are in 110. So right now showing 0.1 milliamps. It's not. Oh, it was on. Okay. Let me go back to voltage, make sure we have AC. Make sure that we still have what we need here. Okay, we have AC there. So we should be able to check. Oh, I was on the wrong setting because I'm an idiot. New meter, no excuse, whatever. All right. So now, it should be pulling something. Maybe you need a load. Maybe you need a load. Maybe, I'm going to come back to this. I'm going to go off camera. Maybe you need, it should be pulling something, I would think. Unless my meter is not set up right. Okay, but anyway, I'm going to come back to the amperage thing. And then I'm going to cut and maybe do a little bit of talking. Okay, we're back with the amperage thing. Sorry, guys. Sorry. Yeah, new meter, whatever. Had to configure the test leads a little bit differently. So, yeah, it was just under no load. Under no load. We're pulling about a 1/4 amp. Just about a 1/4 amp. And I'm guessing this guy loaded is at least a 2. But when we get it hooked up in the power supply under load, running boards, ooh, yeah, we did get a little bit of spark there. That's okay. Yeah, because in amperage mode, your meter is completing the circuit. You need to come in somewhere and let your meter kind of complete the circuit. You need to run the line. You need to run a line through the meter to read the load. So anyway, without load, that's kind of where we are. Wish I would. I'll test the other ones. These two are going to go in boxes. I think we're finished. So, all right. I don't know. Maybe I can swing you up. All right, guys. I don't know if you can see me or not. Maybe you can see me. Maybe you can see me and the workbench. But thank you guys for watching. That's just how to test transformers and things to kind of look out for specifically on the Williams boards. So we definitely have a difference in blueprints and the drawings. So keep, you can't just work off the wrong one, or you at least have to know the differences between them and kind of what you're looking at. And I hope that helped test the transformers. I know a lot of guys want to use their old stuff, and you need a good transformer or you're not going to have the proper voltage running into your power supply, which will like really stress those components, like the components we went through before, those bridge rectifiers, diodes, things won't, the gain is like really kind of in the gain control. If those voltages are not good and your gain controls in your power supplies, nothing will be regulated at the proper voltage, which means your board will not have proper voltage. So what else? I was thinking there was something else. That's it. You guys have any questions? Leave the comments below. Thank you for watching. I think next video I'm probably gonna use that rebuilt transformer, but I'm gonna put a new connector pin. So I'm gonna repin it, stuff like that. Maybe I'll make a video on how to pin sockets. Man, I was thinking there was something else I wanted to tell you guys, but I think that's it. If I think about it, I'll leave it in the comments. So thank you for watching. I hope you found that useful. All right, peace out.